Good evening, everyone. My name is Timothy Cox. This is my Chemistry 126 Advanced Concept 6 presentation. So for week 6, we will not actually be conducting an experiment. We're going to be talking about nuclear reactions. So the description for this week is going to be a little bit different, as nuclear chemistry is not as easy to do at home. So instead, we'll be learning about how nuclear bombs work using the following video as your guide. You will make a presentation on the type of nuclear chemistry needed for a nuclear bomb to work. And so for the instructions, using the information in the video, prepare a 5 to 10 minute presentation on what is occurring inside the reaction and what components are necessary to achieve the chain reaction required for nuclear fusion. So a nuclear bomb basically works by utilizing nuclear reactions to release a massive amount of energy in a short amount of time. The two most common types of nuclear reactions used in nuclear weapons are nuclear fission and nuclear fusion. In nuclear fission, the nucleus of an atom is split into two smaller nuclei, releasing a large amount of energy. This reaction can be achieved using a neutron to bombard a heavy nucleus, such as uranium-235 or plutonium-239. This process generates more neutrons, which can then bombard other nuclei, leading to a chain reaction that releases a massive amount of energy in the form of heat, light, and also radiation. Nuclear fusion, on the other hand, involves combining two light nuclei, such as hydrogen or helium, to form a heavier nucleus. This process also releases a large amount of energy, but it requires extremely high temperatures and pressures to achieve. In a nuclear bomb, the energy released from a fission reaction is used to create these high temperatures and pressures, which then initiates the fusion reaction. To achieve a chain reaction for nuclear fusion in a nuclear bomb, several components are necessary. These include a fission trigger, which generates the initial energy to start the fusion reaction, and a fusion fuel, which provides the nuclei for the fusion reaction. The fuel typically consists of isotopes of hydrogen, such as deuterium and tritium, which are heated and compressed to extreme conditions in order to initiate the fusion reaction. Overall, the nuclear chemistry involved in a nuclear bomb is complex and requires precise conditions and components to achieve the desired outcome. The destructive power of these weapons underscores the importance of responsible use and management of nuclear technology in today's world. So it's important to be responsible with this technology. Could destroy the world one day. Kind of crazy, but that's my presentation. Thanks for listening.